Here's a past paper problem on calculus in motion. We've got a question from the specimen paper for Unit 2, and it tells us this. Particle of mass 3 kilograms moves along the horizontal axis under the action of a resultant force. Its velocity is given by this formula here, 12t take away 3t squared. Given that the particle is at the origin when t is 1, find an expression for the displacement at any time. And in part B, we're going to find an expression for the acceleration. Now this is worth 5 marks, so aim to spend about 5 minutes on the problem. There are a few red herrings in the text up here. For example, they tell us about the mass and the force of an object. But in terms of the workings, we just need to find the displacement and acceleration, which is quite nice. Pause the video, give it a try, and unpause it whenever you're ready to see the answer. Okay, so in part A, we need to find the displacement. And we know the velocity. So to get to the displacement from the velocity, we need to integrate our expressions. If we integrate v, we will get s. Let's do that. The integral of v, so v is 12t take away 3t squared. The process for integration is to add 1 to the power and then divide by the new power. Let's do that here. 12t is going to turn into, I'll sort that out in a second, and similarly 3t squared is going to change into, let's just simplify the number bit, so 12 over 2 is 6, over 3 that's going to go, and we've got 6t squared take away t cubed plus t. That is our displacement expression. Now, they did tell us some initial information here. They said that the particle was at the origin when t is 1. They haven't said it explicitly here, but when t is 1, the value of s is 0. So if it's at the origin, the implication is the displacement is 0. So let's plug these values into this equation, see what we get. So s on the left hand side is going to be 0. We're going to have t is 1 in here and here, and we're going to try and solve this. So this works out as 6, 1, and I believe c is going to work out as -5. Once I have the value of c, I can plug that into my displacement equation, and rather than having, what was it, 6t squared minus t cubed plus c, I'm going to replace that c with -5, and I've got my displacement there. Cool. In part 2, we need to find the acceleration. Let's write that a little bit below. The acceleration, I find that by differentiating the velocity equation. So I'll write down the velocity again, which was 12t minus 3t squared. And I'm going to differentiate this, dv dt, and that will give me my acceleration. Differentiate in 12t will be 12. Differentiate in 3t squared will be 6t. And that's it. That's my expression for the acceleration. Fantastic.